Good morning, good afternoon, good evening, wherever you're sitting at the moment. Luke and I would like to offer a very warm welcome to the Masterclass this morning on real-time monitoring, a practical guide. And before we start the session, we would actually like to start with an acknowledgement of country. In the spirit of reconciliation, we acknowledge the traditional custodians of country throughout Australia and their connections to land, sea and community. We pay our respect to their elders, past and present, and extend that respect to all Aboriginal and Torres Strait Islander peoples today and into the future. So welcome to the session, everyone. We're actually going to start the session today with a poll, which Bo will raise now. We would like to gauge your experience with real-time technology. So how describe your experience with real-time monitoring. Are you experienced in real-time monitoring and video exposure monitoring, experienced in real-time only? Do you have some experience, no experience, and planning to make a start, or not planning to use at this stage? So I'll just give that a couple of seconds. And I might move into just a quick overview of what the session will look like today while we're waiting for everyone just to fill out that poll. So it's going to be a full session. We're going to go into what it's all about, what the benefits are. Luke's going to talk through limitations and planning. We'll go through a bit of how to conduct it with some practical case studies and real-time applications. Luke's going to go through data processing, considerations for the comm strategy, some examples and case studies, and then lessons learnt. And we're going to finish the session today on future directions of the technology. So there is the chat function as well. So if you do have a question through the session, please feel free to type it in there and we'll see if we can get to it. If we don't, We hope to do that at the end of the session. Otherwise, alternatively, we'll leave our contact details there for you to get in touch with us afterwards. So how are we going through with the answers? We've only got 7% of the audience answered so far, and it's looking like a bit of a spread. So that's really good to see. So we've got some people that are quite experienced, we've got some with some, and some with no experience. So we'll really try and take that into consideration through the session today, and make sure that we go through, the first considerations when you're first starting out, and also looking at, more advanced applications as well. So if you continue to fill that poll out, that's great information for us, but we will kick into the session now in the interest of time. So I'm going to start with a bit of an overview of what real-time and video exposure monitoring is. So really, in a nutshell, real-time can be coupled with video monitoring, and the monitoring aspect is basically any equipment that will capture the data in real time and log it. So in the occupational hygiene field, we've been using real-time technology in a lot of applications for a long time. And then I think the difference now probably is that consideration about adding video, which is a wearable device capable of recording high-quality video files. So, for example, a GoPro. And there's certainly some considerations around that, which I'll go into a little bit in the coming slide. And then I think the key aspect of this is really that software, merging that video with the real-time data log to really understand and visually see where those exposures are happening. And I think that is a really exciting thing, and it enables us to communicate very effectively and understandably as well. So looking at some real-time capability sensing, what kind of equipment is out there, and I think that this is a really exciting thing to start to think about. We've seen a lot of applications in dust. So, it might be a survey, it might be personal exposure, it might be a static application, or it might be networked. We certainly did hear in 2018 in the Perth conference, we had Professor Cass Badenhurst from Anglo, and he shared a really amazing application where they'd actually fixed dust monitoring stations throughout their plant, looking at, where they've got key controls. And then they also had control monitoring in place. So, this is, it can be applied in different ways very much. And then I think we're starting to think now about other exposure applications as well. So diesel particulate monitoring, whole body vibration, noise, gases and vapors, and thermal stress. And then there's also the aspect which we could consider as well around worker comfort. So temperature, humidity, noise and lighting. So, I think that this is a real challenge for us to now start to think about, where else we can apply this technology, where we've already got monitoring equipment that is capable of real-time sensing. And so from a monitoring perspective, this is a data log from an AM520 monitor. And I think the power of it is really that instead of getting one result for the whole shift, where we get a personal exposure monitoring result, which is sent to the lab, and we might get that back in a week or 2 weeks' time, and it's one result, we can actually log, every second. So that's, a lot of different values that we're getting through the shift. We can start to see the trends. We can start to map that back to areas that the individual worked in or tasks that they were conducting. So, it allows us to get really into that detail, identify the source, and then that will help us identify what is a suitable control measure as well. So certainly gives us a lot more information compared to traditional sampling. And then from a video perspective, so this is really showing the quality of the video or the lighting that's there. And this is going to come up through one of our applications that we'll share. The video can't really be used alone. I think that's what we're really trying to highlight here as well, is that in the workplace, you might not always see the hazard and visually see that, and the person might not see the hazard. And so then that comes into their risk perception. And we've certainly seen that around things like noise, where you can't see it. That impacts on the person's, perception of that hazard, and then probably their behaviours around wearing the control or, using the controls available. But also around COVID, certainly I've seen on the media a lot, where people don't see it and they might be in high-risk environments and they're not protecting themselves. So I think it's a really important one to think about is, does the worker perceive the hazard, first of all? So this can be used as a really amazing training tool if it's not very visual, but also thinking about, well, where can we use lighting? Where can we get that Tyndall effect to really highlight the hazard to them in that video? so that they know that it is there, and that might influence their behaviour. So that is what it is in a nutshell. So why real time? Why would we move and change and transform our approach to occupational exposure monitoring? Well, I've noticed definitely that there's an evolving workplace. We're starting to see that people are really upskilling or multi-skilling and moving outside of, what would traditionally be tasks within their seg or areas that they would work in within their similar exposure group. So I suppose, this got me thinking when I was looking through field sheets and looking at a field sheet analysis, I started to see that, for example, a process plant maintainer might do hosing where traditionally they wouldn't. But now it's about, well, if they've got some downtime, we can utilise that time. There's other tasks that they can be doing. And I think that this is certainly happening in a lot of industries. However, there may still be industries or environments where people are still quite static. Their job is really well defined. And a seg does make sense. Analysing similar exposure group data still can make sense. But I suppose what I started to notice was that there was a high variability in the results. We were starting to get very high geometric standard deviations. And, that was really due to the fact that people were moving around a lot and also doing very diverse tasks. And every day looked a little bit different. So I'm just going to show a video now that really just highlights, our observations that prompted us to think differently about exposure monitoring.
Meet Tom, an occupational hygienist who has a passion for protecting worker health. This is Jane, a plant operator who's been doing the same tasks in the same area for years, just like her colleagues. This makes Tom's job easy, as he has clearly identified them as a similar exposure group, or SEG. Their exposure data is consistently low risk for occupational health hazards. However, workplaces have become more agile in response to customer and economic demands, resulting in greater variability in work factors. This has meant that Jane and her colleagues have had to multi-skill and work across a number of work areas, completing diverse tasks. In highly variable conditions, and every day is different. This has made it difficult for Tom to interpret and identify control solutions as the SEG data has become highly variable. Tom identifies that there has been a significant change, so he collects more data as a new baseline for the SEG, which continues to be variable. So he reviews potential subsets and collects even more data. And so the cycle continues while these workers perform some tasks with inadequate controls in place. There must be a way Tom can break the sampling cycle and get to the heart of the problem quickly, a way that enables him to shift his focus from sampling to identifying effective and sustainable controls. Meet Tom, an occupational hygienist.
Okay. I noticed in the chat that some people are also having some technical issues. So hopefully that can get worked out. I saw that someone had to sign in or change computers and that resolved the issue. This session is being recorded. So if there are any issues and you aren't able to hear or get in, that's certainly something that will be shared after the session as well. So please don't worry too much that you're going to miss anything. So like Tom, that's exactly the kind of situation that we found ourselves in, where we were almost going around in a monitoring cycle where you kind of think, well, there's a high GSD, there must be a task or there must be an area that we need to focus on and define. So let's do some targeted sampling or let's subseg and get a new baseline for that particular subseg. And, I think that what real-time monitoring enables us to do is reinvent it completely and shift our focus from monitoring to controlling and really break that cycle, because I think that the traditional sampling techniques really do take a lot of time, particularly if you're going to reset a baseline. And I think there's some ethical questions there as well in terms of, well, it's going to take us that much time. Do we have the right controls in place for these workers? We need to do something immediately. And I think that's the exciting thing about real-time technology. So certainly there's a lot of applications. I'm going to share a couple here, but I think that there's a lot of opportunity now as a profession to start thinking about different applications and start to really be creative around where it might be suitable to you. So mapping high exposure areas and tasks, I'm going to show some examples of that, almost like we do from a noise perspective, where we do contour mapping. There's certainly an opportunity for that kind of approach. Prioritizing control measures, assessing control effectiveness, which I think is a really important thing from a stakeholder perspective, especially if, you know, someone has invested, you know, a leader has invested in a control. We want to show and demonstrate how that's working really quickly. Investigating sampling exceedances. I'm going to show an example of that a bit later as well. Developing job role profiles. I think that's something into the future that we can consider. Informing training packages. And then I think very excitingly, starting to combine multiple inputs for holistic personal exposure assessment. So where someone might be exposed to thermal stress, you know, they might have a very hot work environment. They might be exposed to diesel particulate and, you know, dust or noise as well. You know, there might be quite a complex exposure profile. That's something where we can now start to get all of those real-time inputs with that video. And I think, you know, can be used in training. It can also be used when onboarding or, you know, for medical practitioners. I think it's a great opportunity to show, you know, what is the exposures actually in the workplace. If you've got an occupational physician who's reviewing that individual, doing a fitness for work assessment to determine if they're fit to go back into the role, back into that work environment, having that information, having those videos and that exposure profile could be very useful information. So I think definitely a lot of exciting potential applications. So in terms of key benefits, you know, there's certainly a lot. I've only kind of got the key ones here, but I think there's a lot of benefits for this. Definitely efficiency. You know, I think I was starting to get feedback from leaders, and I think they were starting to benchmark against other professions where there's this we're data-driven society, and they're expecting this immediate feedback, you know, because there's a lot of technology out there today in all areas of our business. So they would say, you know, how can we wait this long for the information? We need it now. So I think that efficiency, getting back to our stakeholders is really important, and also keeps them engaged as well. It's a visual communication tool. You know, showing someone and personalizing that exposure is very powerful compared to, you know, showing them statistical analysis of the seg data that's been conducted, where there might be a mean and a, you know, you're thinking about the variability. That's certainly, I think, too high level, and I think doesn't personalize it. Whereas this technology enables us to do that and transport people to the work environment who may not have been there. So a lot of our decision makers, you know, might not have seen a task or might not have been out into that particular work environment. And this allows us to do that really easily, particularly in, you know, this virtual world that we're living in today. So in summary for this section, I think it's an essential tool for us as occupational hygienists. It enables us to become more responsive in today's rapidly evolving workplaces. So Luke is now going to talk about limitations.
Hi, thanks, Candice. Great to see you all here today. I'm really excited to be able to share the journey of real time. I and the business that I work for has been on this journey for a number of years now, and I'm really excited that we can share some of the learnings that we've made. Now, you really are going to be bombarded with a lot of information over the next hour and a half, but the main thing I want you to take away from this is that there are no rules with this stuff at the moment. It's very simple to get involved with and start making a really good impact. So go out, grab some tech and have a go. From our experience, the most success has been from making this as simple as possible. So, yes, Candice just said we're going to go into the limitations and planning. If there's two key things that we need to think about when we start going on this journey is, one, you need to understand the limitations of the device. And secondly, if you don't have a plan, you're going to lose a lot of time and money. Although we as a profession have been using real-time monitoring, like Candice said, for decades, measuring noise and vibration, we're just starting to, we're not quite comfortable with using this for dust yet. And that reason is because we're actually not measuring the mass, we're measuring a surrogate. So, and we're not comfortable because we're working in the grey. But we're not alone here. The AIHA did a member survey, and it found that sort of 50% of people are just as likely to use a surrogate as they are to use a mass measuring, measure the mass of the particulates. Look, I love some of the tech. The thing is, with this technology, it's been a very niche market, and hygienists have only really been using this for a short amount of time. So there has been challenges around the ease of use of this equipment. But as the market and we start to adopt this technology, the market will see that and it will grow, and more and more pieces of equipment will become available. And then with that improved demand, the uptake by workers, we expect the cost of this equipment to start coming down. In a set of measurements, accuracy is the closeness of measurement to the specific value, while the precision is the closeness of the measurements to each other. So some examples to provide point one there: an accurate and precise instrument would be like a laboratory reference sample. An accurate but not precise method of measuring is, for example, our 2985 monitoring that has measurement uncertainty around. It's accurate but not precise, and we saw this in Laurie Grossop's presentation a couple of months ago. Generally, real-time monitors are precise but not accurate. You can make them more accurate by side-by-side sampling and applying calibration factors to these. That can take a lot of time to get precise, and it can be a minefield. And our fourth section here is not accurate and not precise. We'd probably steer clear of that. So we're going to talk a lot about real time during this presentation, but is the measurements we're taking really in real time? So we've got the example here of our video, a fixed point dust monitor. It's sending information into a database, and that information is displayed into a dashboard. The monitor trends and identifies issues that can be acted upon in real time. What we're actually, the equipment that we're talking about and we use often when we're pairing this with video analysis, needs to be set up, monitors for a set period, it then is stopped and downloaded, and then we review the data to determine what it means and where our exposures may have occurred. There is a large range of equipment that you can use for this monitoring. Some measures mass and therefore is quite accurate. Other uses light scattering technology, and there's other types of technology as well, light scattering being a surrogate. The equipment ranges in size from, the size of an office printer right down to the size of a deck of cards. One thing you need to be aware of is the robustness. What is our goal and what are we trying to do with this equipment? We can't put the monitors that are the size of an office printer on someone's back to get them to walk around the workplace to see what their dust exposures are. But we can use the smaller devices for those things. All of these pieces of equipment require different types of maintenance, some daily, some weekly, and some more paced out than that. You need to understand what the equipment limitations are before you try and apply them to your business. There is a range of cost for all these pieces of equipment, from some as low as $10 for the really basic sensors, right up to $25,000 plus. They all have their place, but before you pick your instrument, you really need to determine what you are trying to achieve from your assessments. So before measuring, it's really important to establish why are you doing this? The biggest problem we've seen with people and businesses failing is where the goal has not been determined initially. They go out, they buy a real-time monitor or 20, and they say, we're going to do real-time. But what is that? To start with, you need to determine what your goal is. Are we going to assess workers' exposures, compare results to validate controls, manage workers' exposures below the WES, or use their monitoring to interlock controls? Your goal will help you determine your equipment. Don't buy your equipment and then determine your goal, because more often than not, the equipment will not work for that application. So some general guidance. I said there's no rules around this, but there is some guidance material. There's an EN standard around the guide and use of direct reading instruments for aerosol monitoring. And we have a knowledge bank of what devices are available and different types of technology and how they work and have limitations. We need to understand what our goal is. What is the aim of the measurement we are trying to take? As I discussed on the previous slide. Are we looking for accuracy or usability? Usually the more accurate the device is, the more maintenance it requires, and also potentially the less robust it is. Not in all cases, but sometimes. What is the target audience? What are the outputs of that equipment, and is that going to help fulfill the needs of our target audience? And what is our budget? Success is choosing the right piece of equipment, looking at robustness, battery life, preparation, costs and maintenance, data response times, logging interval selections, calibration and certainty of the results. Ease of use is really important depending on where you're going to deploy this technology. Do you need to develop procedures and training to input this into your business? You need to understand your equipment to then understand if the environment that you're putting them have any constraints on how that equipment is used. And finally, data handling and communication. I'll talk about this later on, but this is a really important part about using this technology. It takes up a lot of data on your computers. It's very hard to email off. You need a central point to be able to store this information and to be able to share it to your key stakeholders. As I've said, there's countless ways to implement this technology. I want to give you some takeaways. In our experience, the two most common areas that we've seen success is using this technology to validate control effectiveness or undertake task-based assessments. Now, these key points that I'm going to point out to you are not going to apply to everybody, and that's why that planning phase is really important. But you know, you should be some of you out there will be able to take some points out of this, be able to get going straight away. Learn from our learnings that have taken so long. So for control effectiveness, something as simple as pre and post control validation. You're going to see a lot of videos around that applied through Candace's presentation coming up. Point source emissions assessments, interlocking controls, you know, building an actual control where we might be assessing dust measured outside of a cabin, for example. When that dust starts to fall out of spec through our real-time monitoring, that then triggers an automated shutdown of the production. Then we might move into like task-based assessments. One that's a big thing, I know over here in Queensland, we need to undertake exceedance investigations. This is really valuable to identify that key source that's causing these exceedances. Undertaking survey measurements and developing TARPs based exposure management to use the real time alongside. Now you've gone to all the trouble and you've identified what your goal is. You've gone out and purchased your piece of equipment. Where do we start? Well, it's pretty obvious. Us as hygienists have a mountain of data, and it's always necessary to then consult the people doing those tasks to tease out the key roles. So in this example here, we've got a workplace. We've identified that our SEG3 is our key priority to undertake some investigation for. It's identified that SEG has three main roles within it. And then through some consultation with those doing those tasks, it's been identified that task one is the priority to start the real-time journey for this business. Now Candace is going to take you through how she's been applying and implementing real-time into the Rio business.
Thanks, Luke. There is actually a poll going on at the moment as well, so I'd encourage you to just have a look over that and answer. It's about which of these real-time monitoring applications would you find most value. So evaluating worker exposures, replacing traditional monitoring, identifying exposure sources to recommend controls, assessing control assessing control effectiveness, and continuing monitoring of hazards or controls. So at the moment, there have been quite a few people, 68% of the audience has found that poll, which is great to see. And 51 or 52 of those answers, which is about 56%, still going, are saying that identifying exposure sources to recommend controls is important. So that's actually really handy, because I'm going to take us through an example of when we first rolled out real-time monitoring and some of the considerations when we were first starting out. And the application was exactly that. We knew from traditional sampling that we had a problem, but we weren't sure, where to guide the investment, where were the sources that were really key. And, we had a number of sites to consider, and we needed to think about what are the priorities. So identifying those exposure sources was very key to that process. So I'm going to go through planning for success, the equipment selection for that application, monitoring preparation, data capture, and some contextual factors. So I think just to reinforce what Luke was saying there, at all times, it's very important before even purchasing equipment, before starting that planning phase, to think about what the goal is, because it will change. Your approach will change, the considerations will change, your stakeholder engagement strategy or partner mapping might change significantly, depending on what you want to achieve out of the process. So, is it to assess worker exposure? Is it to compare results to validate controls? Is it to manage worker exposures below the OEL? Or is it, looking at interlocking controls and getting to that next level? So, as I said, this example is very much around the prioritisation and starting to think about the areas, and almost a bit like contour mapping in a way, how we approach noise surveys. So in this particular example, I was working very closely with a specialist, an engineering specialist. So we partnered together on this project, which is a really great experience, because I think, recognising that my skill set was one part of the puzzle, but really I needed someone who could interpret engineering drawings, who could identify the sources, who could recommend the engineering controls, and help to manage the implementation and design of those as well. So it was really important to partner up front. And then we looked at equipment selection, and we did that together as well. So there was early engagement, and I think that meant that we worked as a team, which has led to an ongoing relationship with engineering, which has been really fantastic long term. We looked at the preparation, and that was really good to get insights from an engineering standpoint as well. I certainly learned a lot through that process. Data capture, actually going to site together and doing the walkthrough. Interpretation and reporting, and that was quite a process as well. So I'll share kind of how we approach that. Area and task prioritization, so that speaks a lot to that, identifying sources and what are the recommendations and what are the solutions that we think are important. Data source identification and recommendations, and then review and assessment of control effectiveness. So we've got a couple of examples of that in this section, but also in other sections of today's presentation. And I think, even before we started to think about equipment selection, we started to also think about applications. So certainly we knew we wanted it to be personal monitoring rather than static, but we also then explored the option of actually putting, this technology on workers. And we met with our external relations team, and we talked about, some of the privacy considerations. And I think that this is actually very vital to think about in that early planning stage, because we worked out very quickly that if we wanted to use video exposure monitoring, it would not be suitable to put a video onto somebody. Our ER experts raised some really good points and said, well, is that reasonable for someone? What if someone else is captured on the video? It's not just about the individual and the consent that they might give to wear this equipment, but what about the other people working around them? And if they might get captured on the video, and, have they consented, and are they comfortable with that? And, there's some safety considerations as well. We have the intent of using this video for a certain application, but if something arises, and that video is then brought in for other applications, that can be a challenge as well. So I think that made us realise very quickly that we didn't want to use this technology with our workforce. Initially, we were going to do a walkthrough survey, so we were going to use it ourselves. And we did engagement up front with the sites, and we let the teams in those work environments know what we would be doing. And when we started that process, we had escorts, and we made sure that we weren't capturing them on the video, etc. So certainly privacy is a very important consideration. So in terms of selection, we trialed a couple of different options. We were trying to capture the inhalable fraction. So we did trial a really kind of old piece of equipment called the Split 2, which required an active sampling pump that was separate to the main unit. It was very heavy and cumbersome. The software package was really dated and difficult to use, but the benefit was that you could actually send a sample off to the lab. But I found that, it was very challenging. And I think it speaks to that point that Luke raised about, is it precise and accurate? What do we want to get out of it? And for us, it's, precise, not accurate, but certainly comparable. And that's what we needed. We just wanted to compare different areas and different dust sources and start to kind of, look at the same operating conditions. So that was really our aim. It wasn't about getting that real precise, that real accurate outcome. So we decided to go with the AM520. And I know that there's certainly a lot of other options out now. This was a little while ago, but it worked really well for us. So we looked at the key features. It did do various particle sizes. It's real time only. It has an inbuilt pump, so it's really lightweight, which was a real benefit for us. And it had a great software package supporting it as well. It was intuitive, the easy data download process, and it was user-friendly software. And the data analysis capability was really great as well, and reliable. We found this to be a really good one. At that stage, one thing that came up was that it didn't come with a protection case, and that in our environment was quite challenging. And I know that other companies have solved that and thought about, designing something specific. So I think that that's a consideration as well, particularly depending on the environment that you're going into, because it is expensive equipment and you do want to protect it. And then we chose a GoPro camera, which we helmet mounted. So we got some, stickers that you can buy off the shelf, put it on the helmet, which was really easy. It didn't make it too heavy or anything. It's really quite lightweight, which is great. And it gives you a really great view as well. We did use the Handbrake software, so for file compression. So the high-res videos are really large. And with Evade, what it does is it links to wherever that file is saved. So this is one of my hot tips for this session, is that I've come unstuck before where I've thought, it's actually embedded in Evade. And if I save the Evade file and I put it on a USB and I go to present it, that'll be fine. But it actually tries to find the source. So if you've got it saved on your desktop as a video file, that's where it's linking to. So always make sure that your links are working so that your video will play when you've got to present that file. So file compression was important, getting a smaller video file for saving, and also audio removal. So certainly, again, from a privacy perspective, we were being escorted through the site. People would have a chat with us. We're talking about, our families or whatever we're talking about, the work environment. I think it's important to remove that audio, and it also takes the distraction of that audio out when presenting to leadership. So, the video was great quality, the angle was good. There were large files, as I said, and there was limited storage. So we had to buy a couple of different storage, little extra file savers that they come with. I'm thinking of the word at the moment. Someone write it in the chat for me. But we had to have a couple of those on us because we would get through that really quickly. If you're doing a survey through the day, SD card. Thank you so much, Christy. And Peter. Yes, an SD card. So we had a couple of those on hand because we would work through that really quickly. If we're going to go do a whole shift, a whole site, we needed to have a few. And then also with the battery would run out. When you're in the field, you've got people escorting you, you've done all this preparation, and then you've got your battery runs out and now you can't capture what you're seeing. So important to have all of those backups. And there was an issue with no timestamp at the time. That's probably not so much an issue with the newer models now, but certainly it became really important for us to take a very good log when we're out in the field of where we were, where we started, so that we could marry the data file with the video file later on very easily. So those were the key considerations. In terms of the preparation, so this was really good process to go through with an engineer. We kind of contacted those sites well ahead of time to get some information. So we wanted to make sure we had the shutdown schedule. You don't want to get there and there's pieces of equipment that are shut down and you can't do that monitoring. We had site contacts and escorts arranged. analysis of exposure data and field sheets. I think it's really good to go through the data that we do have available to us. So, you know, if we've done a lot of traditional sampling, a field sheet analysis, and I've got that a bit later on, is a really great thing to kind of identify the trends, the areas and the tasks that keep coming up that are associated with the higher results that we see. So, you know, certainly we can still use that, and that is accurate and precise data as well. Processing plant maps so that we could map out the ways that we were going to walk and be quite strategic around that. Location of control measures, engineering drawings, the dust suppression and extraction system status within each area. So looking at critical controls and how are they operating. And then, you know, measurement equipment manuals, definitely when you're using it for the first time, very good to have all of those handy and do a run through before you get there. There's some questions around how long do the batteries last? I think they would last quite a while, you know, good kind of 4 to 5, maybe 6 hours out in the field. But, you know, we would just have a backup because we were having 12-hour shifts, and often we were trying to get through a full site, so we would have long days. So we always just had a backup for the camera. Is it the camera that you're asking about there, Jen? Just respond. Let me know if you're looking at the camera or the AM520. So in terms of data capture, it is very important to, I think about all of the different aspects that can influence the results, because it is a snapshot. So that's one of the limitations around this compared to traditional sampling, where you're trying to get a range of results across the year, thinking about, you know, different jobs. It's, you know, it's kind of reflective of all the different scenarios. So one thing to consider is it is a snapshot. So the environmental conditions can be really important. I've certainly gone to the same site where it's rained in the lead up to the survey, and, you know, things are quite wet, and the results will be, you know, really different from it being a really dry day with, you know, a lot of kind of much dustier. So, and also, you know, the kind of material that's coming through. So depending on your work environment, definitely think about if it's outdoors, the environmental conditions, what are the weather conditions? I'd be capturing that for comparison later down the track. So looking at wind, you know, that can have a big impact as well. Vehicle traffic, if that's a consideration. And then operational. So certainly production levels, operational status. If there's a shutdown in progress in one of those areas, that can have a significant impact. And then, you know, what is the operational status of the critical control? So in our case, it was the dust extraction and suppression systems. I would always be checking that and noting that as part of the report. And then looking at time and geospatial. So the timestamp, as I said, we always wanted to kind of know where we were so that we could marry that all together later. We would land up after these surveys with, you know, sometimes 20 areas that we've assessed and some tasks that we've assessed. So we certainly want to have that log very well organised. And I certainly left that up to the specialist engineer that we worked with. He was very good at keeping that very consistent and accurate. And then a location correlation. So we kind of captured the location, the time, and some observations that we could see within the area. So it might be, you know, some of the potential dust sources. If we could observe something that could be an easy, quick fix, we would certainly put that down and make that recommendation as well. So the data capture is where we're on site and actually doing the monitoring, doing the sampling. So it's important to have all of our ducks in a row before we get there. This is just an example here of Evade. So where we have gone and done the marrying of the data capture and the video. And this particular one is the belt to take up tower here. So, you know, I think that this is just showing how easily you can see that. And Bo has put up a link there that you can click to freely download the Evade software. So it's on the NIOSH website. It's free. I think they've actually recently put up a new version of it this year, which is great. And it's amazing that it's so accessible to everyone. I think it's a really great tool. If you don't have this kind of software in your company that has been developed, or, you know, you don't have someone who's kind of using or has access to other systems, and this one's freely available and works really well. Just to show another example here. So this one is a vibrating feeder. And I think you can see here as well, I'm just showing a couple of different examples because you can see the lighting also has an impact. So here you can see that very visually. We can map that back to engineering drawings later on. But I think, you know, these are great shares. Often I would use a little snippet of something that where we're recommending, you know, a critical control is implemented soon, an engineering control. I'd take a snippet and say, look at this, you know, this is the work environment that people are in, and imagine what it would be like if that was your work environment. I think it's also a really great tool to be able to get leaders, who might not be site-based or are site-based but aren't going out into the field that often, to really think about, well, what if that was your work environment every single day and you were, and that was the norm. I think that also kind of really triggers how that might, feel to work in as well. So certainly that visual is so important. And this is an example of a transfer point. Now, this is poor lighting. So as we showed that video initially, where the lighting makes a big difference, you'll see here the results are actually really high, but you can't see that you can't actually see the dust very well. I've had a lot of people say to me, well, do we need to, do this process? You can just see it. You can kind of do the walkthrough and you can observe it. And I think, well, absolutely we do, because it makes it comparable. It gives us the data points to really take a more quantitative approach and to that prioritization, or to highlight that task or that area. But also it means that the decision makers can see it and they can get that quantitative data. Often the decision makers want to see the data. So I think it couples those two things together to really make for a very compelling case. And so this is an output of what we developed. So this was early on. We did this work kind of in 2016, 2017. This was the beginning of our real-time journey. And we thought initially, well, let's prioritize. Let's start to look across the sites. We assessed 7 sites, and let's start to think about how we can prioritize. So we were walking through, we were data logging every second, and then, we were kind of just walking and then able to assess, those work environments and compare the different dust sources. The other factors that we needed to consider when we were looking at these priorities was, first of all, were people working in that area? Because I think that's important as well. How often are they working there? What is the exposure duration and how many people? When we're thinking about investment, where do we go first and what do we solve first? That's important consideration. The other thing is, which is great with the video, is you get the real-time data, but sometimes you might have your hand on the handrail and you might, just kind of rub your hands together if you've got gloves on without thinking. We often kind of do this actually out there in the field, and I didn't realize too much until we started to analyze the data. So we were seeing that we were getting these really high peaks at certain points, and then it didn't align with the video. So it's really the video actually gives you that great source of information to say, well, actually, is that reflective of the work environment, or is that reflective of what we were doing, which is also an exposure that is probably happening in the work environment as well. But for prioritization of controls, it's important to marry those together and ensure that it is a legitimate reflection of a dust source that, for an engineering control. So this is an example. As you can see, I've captured there the wind speed. We linked in with our environment team. We had some, environmental monitors on site that we could get some accurate data from them around these things as well, so that we could compare that again. If we come back later to do another one, we can kind of see what the differences are. And certainly, as I said, we assessed one site after rain and again later in the year, and it came out very differently. So very good context. This is just another example. So you can see it was different. You can see sometimes as well with that previous one, there was kind of one really high peak and the rest was quite low. So those are things to factor in as well. Some of the areas, had some multiple dust sources, lower peaks, but, the potential of exposure duration might be longer. So, certainly different factors to consider. And from a GM perspective, the report writing process, I think, is a really important one too. So we weren't writing huge reports on this. We were trying to make it really understandable. So we were using snippets of video and data in the report, in the PowerPoint presentation that we would do with the site leaders. And then we were kind of, from a GM perspective, showing them, the priorities across the site based on that data. And then a slide just highlighting what are the key critical controls that we see in each of those areas as a priority to consider for a critical control, engineering plan, and then looking at interim controls as well while those are being developed. And it certainly enabled us as well. We identified certain areas where people, through our traditional sampling program, we hadn't identified them to require respiratory protection, fit testing and health surveillance. And, that certainly came out through this process as well, is that we'd actually missed a few things through that traditional sampling program. So definitely opportunity to put controls in place immediately. And then later in the report, we had more detail. So this would go, this is certainly for the engineers, it's certainly for the leaders of the area. So for the manager of the plant, we would go into more detail. And we found, because they didn't have Evade, you can't just send the Evade file out. So we thought, well, it's great to have, the graph of their area. We did actually end up putting in a target concentration because you cannot compare this directly to the OEL at the moment. But we did that. We kind of called it a target concentration because we do want to say, well, where do we want to get to? I think that's important as well for context. Where are we now? Where do we want to go? And then we use still images to really highlight, those peaks and the dust sources and how we'd identified on the engineering drawings where they were. And then on the following slide, you can see there that we've called out 4 areas in this dry plant. And then in the key recommendations, we've covered the recommendations for those areas, for those dust sources that we've identified. And we've also covered off on some key observations as well. So, there might be spillage, there might be, were the dust suppression, dust collection systems working well, operating, on the day. And how well were they operating as well. I think that's really good information to capture. So this is just another example. They were quite diverse, and I think it gives good context to go into each area. So have the overarching for the upper management, and then have the detail in the report as well with specifics. So all of these recommendations weren't captured in that first slide, which was really about the key controls we're recommending. There might be some improvement opportunities that might come a bit later. And that fed into a control monitoring plan. So in total for this particular process, which was the first one that we undertook, we assessed 7 sites, as I said. We were also able to identify some common high dust areas. So screen houses, tunnels, apron feeders, transfer points, primary crusher, secondary crusher, and reclaimers. Were pretty consistent across those 7 sites. And that also allowed us to do some feedback to our project teams, for those who are designing new plants, where we can start to improve on those designs so that we don't see those same issues on the new plants coming in online. And then we can start to retrofit controls to the existing plants. And then, the intent was to implement controls, and then we can do some pre and post validation, which is another process that we can go through a bit later. This one is an example of that control effectiveness. Now, I think this one also kind of raises a good point around water suppression. So where you've got small droplets of water, particularly if it's fine sprays, it can impact on the results that you'll see through some of the real-time monitoring devices. They will be you'll see the results go quite high because they'll be captured as dust particles. So what I did in this case was, I think very visually, you can see the impact of the sprays versus sprays off. So, it really does show. And I think that we were starting to see, the sprays were on sometimes, not on sometimes when we went into the work environment. So it was a way of training and, showing that very visually to leaders and to people working in that area to say, well, these controls are really critical and they need to be on all the time. And you can see the difference there very much with them on and with them off. So I think, that's the kind of thing that will prompt that behaviour change. Whereas if we just had the data, I don't think that we would get that same buy-in. So I think 3 key takeaways from this particular application was that real-time is best practice. It certainly allowed us to identify dust sources, prioritise dust management strategies in occupational settings. The collaboration, I think, is really key to this. So we partnered early with our engineering team, and we worked together on it, and we both owned it. And that meant that, the engineering team is really invested in following up on those control measures and working toward implementation, and also assisting us with that control assessment later down the track too. And in the process, on some of these sites that we visited, they landed up purchasing this equipment. And in a lot of cases, we trained engineers as well as the occupational hygiene team to use the equipment so that they could go out and do the checks as well. So I think that that's really exciting. And then communication. So throughout this process, communication is key. And I think that the technology and the outputs allows us to do some really great engagement. It's often in my role, I'll get opportunities to maybe have kind of a 2-minute health share or hygiene share at the beginning of the meeting. And this is a great thing to be able to pull into that, just to generate some discussion and to talk about, what we're identifying, the technology that we're using, but how we can then, how that can influence control measures. So in terms of applications, I want to talk through the next application phase that we had. So following that kind of prioritisation piece, we started to think a little bit differently about segs, because as I mentioned, we identified some examples where we hadn't actually picked up on people who we wanted to capture in the health surveillance program through traditional sampling. So we started to think more about, areas and tasks. And what prompted this was we did a field sheet analysis in preparation for a lot of site visits, and then we started to think more broadly, and we started to do that across all of our sites, working with the site team. So we would look at what trends we were seeing with tasks and areas. We would also look at those real-time monitoring baseline assessments where we walk through the whole plant to identify, certain areas. And then we could start to define areas and tasks instead of potentially using SEGs, which I think is a big shift in thinking. But I want to talk through this a little bit and how it applies and potentially some of the benefits of this kind of approach. So here we have an example of hosing. And I show this one because a lot of leaders would say to me, well, hosing's a wet task. Why would we see high results for dust and hosing? It's a wet task. And here we actually used a torch because we couldn't see it very well. So we used a torch to kind of highlight that in the video a bit more. And straight away, when we started to feedback on the results, I think from a task perspective, very appropriate for us to kind of flag what the maximum is and then set a target, say, this is where we want to be. So this is our percentage at the moment above that target concentration in this particular setting. And then, really in the future, we want to get to 50% of that target concentration. So that's the amount of time, 95% of the time in this task that, the individual is above that 50% of that target concentration. So that really, I think 2 slides very easily highlights the problem, transports that person to that environment, and they go, okay, well, actually, no, my perception when you go there and you see it, it's definitely a dusty task, or can be, depending on where they're doing it. So that's around tasks. And then from an area perspective, and I think this is a bit like that, we would do the noise contour mapping, and you think about, well, where do you, if you're going to put an interim control in place and you need respiratory protection, where do you assign that? And in this case, it's a screening, a screen house. So there are multiple levels of this screen house. There's different dust sources. And you'll see here on the next slide, this is kind of the reflection of that whole area. And there's, as I said, I flagged some key, with the engineer that I was working with, flagged some key dust sources there and some recommendations for controls. But when determining interim control measures, we made the recommendation to make it a mandatory respiratory protection area, and capture the people working there. Anyone entering has to wear respiratory protection. We need to do fit testing, and we also need to make sure that they're captured in the health surveillance program. So I think it's a great way to say, well, here's the data that backs up why that's a mandatory respiratory protection area. And then the exciting stage, which I'll talk about next, is how we can then embed that into our critical risk management program, which is something that our safety teams are using extensively, and much more leading indicator, much more of a prompt to actually use the critical controls. And then I think from a task assessment perspective, this one is done at a gypsum lab. So this is where we've actually used noise, and we've measured noise and we've measured dust. And this was in relation to a sample exceedance that was very unexpected. So usually very low results we were getting, and then we got this result and we thought, well, how did that happen? So we went out to the work environment, and we actually, it only took about 40 minutes to work with this worker on different control combinations. So we assessed it there. You can see that there was only one control combination that resulted in quite a high result. But if I play that video again, you can see it's not that visible to the worker. There's a little bit of dust that's visible, but it's not that visible. They probably aren't thinking that that's going to be a significant health risk. But when you then say, well, hang on, let's look at how that plays up with the different control combinations. So it became very clear. We were data logging, when we changed the control combinations. We didn't have to stop and start. As I said, it was only about a 30, 40-minute process. And straight away, we could see that the best control combination with the lowest risk was extraction systems operating and brush cleaning. And then the highest risk, which was probably, what caused that exceedance, was compressed air without extraction system operating. So the outcome is really clear. We made the recommendation that is a critical control, should always be operating the extraction system, and we should always use brush cleaning. So you can engage the leadership team on that, and then you can start to embed it in the critical risk management program, where they have to check every time they're doing a task that those controls are working well. And then we got to the point where we were defining tasks. So as I said, the field sheet analysis, we were looking at the real-time monitoring outputs, we were looking at ventilation, inspection outcomes, personal field sheet analysis, and then we were able to define mandatory areas and tasks. So this is the back end, this is the data review, documenting our professional notes, and then the output of that is going to high exposure tasks and areas. And what we could see was that all sites had very similar high exposure tasks, except for one site. And then we flagged that task with other sites to start monitoring that. And then we could define areas for each site. So it becomes, I think if you compare this to a SEG profile, where we might say, well, these are the SEGs that are non-conforming, or these are the SEGs that are 50%, over 50% of the exposure standard. This speaks more to the controls than identifying the SEGs. This speaks more to, well, where do the controls need to be in place and when? And then you can make that connection. As I said, we've got a critical risk management program in place with a CCC, which is what we call our critical control checklist, with the operators have to do before a task or area. If they're working in one of those defined areas or tasks, they have to do that. And then ask the question, do you know the areas and tasks where mandatory respiratory protection is required? And if the answer is no, then there's an education aspect there that needs to happen. But it's really asking them, do you know when or where you need to wear these controls or have controls in place, or make sure that the extraction system is operating or the dust suppression system is operating. Bo has put another link up there, and that's an Evade software demo, which you can access to, and it's a great one that's been put together. We were going to do one, but it's actually really thorough. Luke found it, and it goes through how to use Evade, how to import the different files so that you can use multiple data inputs and a video, and how you can kind of represent that visually. So now move over to, so Luke is going to talk about data processing.
Just a little bit clunky sharing. Sorry, everybody. So yeah, I'm going to touch on data processing. Thanks for that, Candice. That was really interesting, and seeing how that they've executed this technology within their business. It's a lot of great takeaways from that for everybody. I'm really just going to touch on data processing. We get a lot of data out of real time. It's potentially logging every second. And I know as a profession, we really love data, but to be honest, the simple metrics are really the best for using this technology. Simple data analysis. So there's a journey you need to go on. As your maturity grows, you will move through the complexity of analysing this data. But really, like I just said before, simple is best to start with. There's definitely no method existing currently for standardised analysis of this data. And there's lots of groups working globally currently undertaking research to try and establish a method. Very simple ways of using this information: observations and basic histograms. That is probably the key first point when you start using this technology, where you get the most bang for buck. Literally showing a histogram and the video to the workers or the workforce or the management team, just as Candice described in her case studies. That is where you get your bang for buck straight off the bat. It's super easy and really, really easy to develop. Then you can move into some basic descriptive statistics and potential comparison to the mean. And I've seen up in the chat on the side while I was watching Candice's show, can we use this to compare against the exposure standard? No, we technically can't. Definitely not. It's not going to replace our regulatory sampling. But in the absence of any sort of guidance on what point we start to intervene, sometimes can be useful. And definitely it provides an indicative estimate of the exposure, and it gives us a point to start from. But we're not replacing our traditional exposure monitoring with this monitoring. As we move on with the complexity, we've got some moderate sort of statistical parameters that we can use. We can look at excursion limits, look at establishing a normal range, which I'll show you some information about. Descriptive statistics using percentiles, geometric means, standard deviations, all the stuff that we're pretty used to in our general data analysis. And then there's some quite advanced stuffs, which I'll touch on. But critically, what you need to do is match your output to your objective. So if your objective is detailed analysis of a million investment in a control, you probably need to use some more advanced techniques. But if your objective is just to engage with the worker about adopting controls, the simple outputs being the observations and the histograms are the best. So we've got our simple ranked measures, stuff that we use all the time: geometric mean, median, 95th percentile, max. And there's definitely, I've put the delineation in there between comparing to the OEL or the excursion limits, and use that proviso that I gave there earlier. But this does help potentially guide us to where we need to focus our controls. If we have a look at these tasks here, our basic descriptive statistics sort of identify some key areas, but the excursion limits and the time above OEL also help us identify where we might want to focus our time. Now, there are many advanced ways of reviewing this data as well. This is definitely a point where I step out and we get someone, if you're lucky enough to have someone like Peter Knott, who we all rely on with our business to do the analysis of this stuff, then go for your life. But realistically, you need to be at a very high level to understand any of this. There are some, measures that we can use about peak analysis, average peaks, maximum peaks, time between peaks. But time series analysis of real-time data can be very complicated. There's autocorrelation among successive measure issues, left censoring due to limit of detection issues. There are some remedies for this, such as the use of Bayesian statistics. But at the end of the day, really, we can get really deep in our statistics and the data on this, but the basics is usually the best. And at the end of the day, the fundamentals still apply. You need to ask yourself, why are we doing all this work? And is all this work actually going to help us meet all of our objectives? Communication strategies. As with any organisation, communication, we need to adapt our communication to our audience. Here's an example of what we've seen to be successful, but you need to consult and find your own way. Basically, what we need to do is we need to be able to inform all of our key stakeholders, us as the hygienist or the technical expert. And our key main 3 points within that band are our workers. They need to be informed. The information that we feed back to them needs to be simple, timely, and we need to be able to give them personal feedback. That's really where that histogram with the video or the picture is really valuable. They can see exactly what they're doing and the work that they're undertaking and how that impacts on their exposure. They have a lot of control over how exposure is managed, and it's amazing that how with some small changes within how they undertake their work, we can get some significant reduction in exposure. Supervisors need to be, again, provided with simple, timely and actionable information. They are our people on the ground in the field all the time, and they again have a very strong big role to play in the use of the information that's provided from this. They can use a lot of the learnings to intervene on exposures, but they can also help advise and educate the workforce that they have under them as they're in place with them all of the time. The owner really manages the real-time program. They need relatively small amounts of information, review the data on a monthly basis, and they need to just be made aware of where the data is heading, what's it showing, and is everything being actioned. We as the hygienists are responsible for ensuring that the data is interpreted correctly, but equally as important that the data is usable by workers. As hygienists, and I'm to blame as much as anybody, we love to complicate things with data. More and more data paints a better picture in our head. But when we're talking back into the workforce, it needs to be as simple as possible so that we can get them to take on the information and make it meaningful to them so that we can get some change. The other key part to this is we need to frame what this information means. Most common question that you're going to get is, how does this compare to regulatory sampling? We need to probably be able to answer that question, and as we have in previous discussions. So this is a familiar situation, and Candice showed a couple of these earlier on. So this is monitoring a situation. We look at this data and we're trying to determine where we need to undertake our action. Having a look at it in 30-second logging, we've got our massive big peak there, which potentially is where we need to focus our time. But we need to be wary that sometimes these peaks can be fake. And again, people have been discussing this in the chat along the side. It can be complicated by aerosols, water aerosols, as Candice discussed with her demonstration of the ROM, but also dust tubing on the sidewalls, or they can even be irrelevant to the real exposure potential. Again, someone dusting off their gloves. But as we sort of average that over a period of time, so 2 minutes, then 5 minutes, and then 10 minutes, the peak becomes less. And really, especially when we're talking about dust, which is a chronic hazard, your priority should really be the mass underneath the curve. Simply being able to use the data to identify which specific area and task is our priority is a great leap forward for most sites. Now, don't get me wrong, as I sort of touched on in that previous section around data analysis, we can do a lot with peak assessments, and they do play an important role. But I would suggest, and some of the learnings from us has been, pick the low-hanging fruit first. That time exposure underneath the line, mass underneath the curve, is really a good starting point. We've also found success in communicating this information by establishing a normal range. This is established over an initial deployment period, where we've established a normal range for that site. When we have any measurements falling outside of that range, that triggers a need to investigate and intervene, usually via a TARP, or a trigger action response plan. You don't even really need to have numbers up the side. You just establish your normal range with a line, and when it starts to fall outside that range, that's where we need to intervene. Once we've established this range, we can start to move towards continual improvement. As you can see here, we've established a normal range in this situation. This is using a fixed point monitor, but it works exactly the same with using personal real-time assessments. Once you've embedded the process into the safety health management system, ongoing review and intervention can actually lead to the establishment of a new normal range, while building in continual reduction to alarm. So I'm just going to run you through a couple more case studies because, hey, who doesn't like seeing a video? So this was a case study that we had recently within a quarry. Using that process that we outlined earlier on, we identified that the maintenance seg had some issues with overexposure to dust. Reviewed the tasks, and filter maintenance was identified as a key priority for the assessment. Assessment was undertaken on the original task, which we probably didn't really need to take the assessment, as you can see by the video. It was pretty out of control. It was identified, obviously, as our priority for control then. A workshop was undertaken with the business to identify some possible controls, and lo and behold, it was identified that there was a washable filter available for this application. Again, we undertook a post, and as you can see here, post-control change assessment was undertaken, and obviously, pretty clearly, we've got a reduction in exposure. We've gone from having measurements up around the 18 milligrams per metre cubed down to barely registering. So a great show there, and actually probably what you're picking up there on the right-hand side with the water spray was actually water mist. A second assessment that we've undertaken recently at a mine site for the task of tyre fitters undertaking rim buffing. Two relatively basic, simple controls were put into place where they were applied, and we were able to see a great change. As Candace sort of said, that's really, you actually can't see a lot of dust being created here, but using the monitoring equipment actually really helps point out that there was a significant amount of dust being created. There was on-tool extraction applied as one control, which did definitely make an improvement. And then a secondary control was trialled as well, which is pre-washing the rim prior to then undertaking some wet grinding. Both were effective, but this identified that the pre-wash and wet grind was the better option. The last one that I'm going to show you is a striker inspection. And anyone who's seen the couple of presentations I've done on this before, this is one of my favourite. It's super clear to be able to see the massive change that was made. This is a task that's undertaken in not only quarries, but on mine sites as well, where we have mobile crushing units. Striker inspections undertaken about once every hour. There's obviously, as we can see, an ongoing issue with dust emissions when undertaking this inspection. The process of the site obviously identified this, it's quite clear, but they identified a control that they wanted to put into place. In this situation, it was foam suppression. And this assessment literally took 15 minutes. We were able to turn the control off, do the walkthrough, and then put the control on and do another walkthrough. This was then being able to relay to the workforce and across the business as a best practice for when undertaking this work and using mobile crushers. So we've gone through all of this information, and I did say that there was going to be a lot, but now this is what we want you to take away and be able to learn from and start using in practice. So when we're using, so from the lessons learned, people, simple is often best. Like I said, histograms and videos, engaging with the workforce on the ground. That is where we get a lot of value built very quickly. Operations adopting this technology is impactful. We need operations to be the owner of this. It needs to be operations-led, not hygienist-led. We need to be able to support the operation to adopt this. We must understand the device limitations for the many reasons that I've touched on previously. Video is staged for this purpose. So often these tasks and these assessments are done in a staged manner. There is some reluctance, definitely from my experience being a consultant, having someone going around and taking videos just willy-nilly within the workforce. Having the stage and the process controlled if possible, and those at least two of those examples that I gave previously, they are able to be staged. Makes it a lot easier to get buy-in from the workforce and the site potentially. And personal devices lead to self-discovery by workers. Those workers being able to see that information on their hip leads to self-discovery and good changes made within the workplace. Plant equipment. The key is making sure you decide, and as I harped on about earlier, get the right piece of equipment. There's so many times when we see these very expensive pieces of equipment sitting on the shelf or waiting to be repaired. That is because the site has not gone out and done the research and identified what is the best piece of equipment for their purpose. Whether that be it wasn't practical to use, or they didn't realise the maintenance that was going to be required to upkeep that piece of equipment. These devices aren't bulletproof. You need to maintain and be prepared that you're going to have to do that. Some of them require daily maintenance, so you need to understand what those maintenance requirements are. Another challenge is installing proprietary software, especially if you're in a large organisation. You'll have restrictions on initial installs, and then updates can be a challenge. So you need to think about that when you're identifying any equipment that you might want to take on board. Also, time to download the results. If you're looking to deploy this within the workforce and you're potentially wanting operations to take this over, one, you need to consider how easy it is to download, and two, how long. Workers are not going to sit around at the end of the shift for an hour trying to find a laptop, downloading software, and then uploading it into the standard location. We need to make these things, or at least understand what is going to be required. From the process point of view for lessons learned, I've harped on about it about 20 times now. Define your goal. No one size fits all, but if you go through that workshop and identify what your goal is, that will set you up for success. There is definitely a lack of standards and training available currently, but that gives you license to have a play around and see what works best for you. You need to understand where to store your data. I think Candace touched on this before, and a couple of people in the chat as well. The storage of data, this puts out some large files, and we really get the most impact from being able to share this information. Most of the time you cannot send this via email. So you need to have a standard format for storing this information that can be easily shareable, especially to the key decision makers and influencers within your business. Calibration factors, I touched on them earlier. They can be a Pandora's box. They can make this a lot more accurate, but they can take a lot of time, and you can invest a lot of time into that, where you really could be out in the field getting amongst it and making some significant change from the start. This is how we see the real-time journey looking. So in the front end, that's where we're all going to start, and probably where the majority of us are at the moment. We're identifying some trials. But this is the stage where we're finding where the value lies for our operation. We're setting a goal, we're moving towards it, and we'll learn, and we might actually even change our goal. That's where we're building confidence in our information with our stakeholders and providing that basic information feedback. As we, if we look along the bottom part of that line, you'll see the hygienist-led and supported by operations, and then we start to shift to an operations-led supported by hygienist. This is where we see the most successful way to deploy this. It is very difficult to mature and scale without ownership by the operations, by those risk owners, by the control owners. They need to own this, and we need to support them. And the way this sort of is going to move is, once we've identified everything, that future state is fully integrated control locking. Like I said about earlier, interlocking controls where we might fall outside of a normal range, that will trigger an operation, a process shutdown. We might be moving towards, instead of monitoring for dust, we might be monitoring for that the control continues to work. In the example that Candace showed, our critical control that was identified with the crushing circuit was the water sprays. We might have a real-time a pressure sensor on those water sprays. When those water sprays start to fall out of their normal range, that triggers a need to go and intervene. So instead of monitoring the output, being the dust, we're monitoring the control, so before the output is even an issue. So the key takeaways that I want you to take away: this isn't just about dust, although this whole presentation has been. There are definitely other types of technology that we can use, be it for noise, vibration, gases, fumes. This can be deployed in many different ways. Planning, planning. Decide what your goal is, and that's going to drive what you're going to do with your outputs. True success is about integrating this into operations. So operations-led and hygienist supported. We need to work together. The international community are all working to solve the current challenges. And the more that we pick this technology up, start using it, and start sharing information, the better and the more understanding is going to be within the whole community. And my final point is, don't be scared. Have a go. Go out, grab some of this technology, start using it today. You are going to make a change as soon as you get this out into the field. It is so powerful.
Thanks so much, Luke. That was just really great and so good to see that there's so much happening on the chat, and people are really starting to get a bit excited, and I think a lot of people actually using this technology, which is really exciting to see. I just want to touch on a few things from a future direction perspective. I think certainly what Luke mentioned there around monitoring controls is where it's heading. And having that situation where you're actually monitoring control effectiveness in real time, and that might be even from a water perspective, we might be looking at chlorine residual, and actually getting that real-time feedback to the teams who can influence that control. So I think that the benefit of this is it really is understandable, and you can have a software package that supports it. You can start to look at the ventilation throughput. You can start to look at capture velocities and transport velocities and how that's working, and then also think about having some static strategically placed fixed monitors from a dust perspective that look at if that control, look at the relationship between the critical control and the dust in the area, that can then trigger immediate response to rectifying that, rather than waiting on personal monitoring, which takes a long time and hard to do that investigation and pinpoint the source. So I think certainly allowing us to shift our focus from monitoring to controlling really well. So some of the other things which I found really interesting and thought I'd share today, one is this TNO website. I came across it. I contacted TNO. They are developing what they're calling the virtual occupational hygiene assistant. And they're doing a lot of research in consultation with other partners. I think one of the partners is University and NIOSH, but certainly check out the TNO website. I might play this video. If you can let me know in the chat if you can hear the audio with a thumbs up, that would be great. I think it's a good overview of kind of what we've discussed and where we're heading with this.
Occupational diseases. Despite significant control efforts, yearly thousands of former workers die from occupational exposures, and even more are injured or suffer from health effects. The diseases are caused by a range of different exposures that workers may encounter at work. Currently, to prevent occupational diseases and to comply with regulatory requirements, we occasionally monitor personal exposure levels for a single exposure by taking samples from the breathing zone, followed by laboratory analysis. With this approach, the measurement results are obtained long after the exposures have taken place, lacking insight into peak exposures or variations over time, and hampering direct action when needed. To further prevent occupational diseases, we need a way to monitor our working environment more continuously and in near real time. Therefore, TNO is developing the Virtual Occupational Hygiene Assistant, VOHA. With a flexible and modular system of sensors, VOHA measures and can collect different kinds of exposure data, such as particulate matter, volatile organic compounds, and non-chemical exposures like noise and temperature. The real-time data provided by VOHA gives valuable insight in and overview of the current exposures. Based on detailed information on where and when exposures occur, sustainable behavioral changes can be enabled or working procedures can be adapted. VOHA can also automatically give the users
I'm actually going to stop the video there, but we have shared the link on the side because we're just in the interest of time. I think, there's a couple of other points we want to make, but I would certainly encourage you to check it out because I think that it shows, using that kind of supporting software and where we're heading, looking at the work environment and being much more responsive in real time as well in terms of those controls. So I had approval from TNO to share that today. They're looking for input at the moment in the development stage of this technology from occupational hygienists and other stakeholders. So if you're interested, I encourage you to check out the website, and there's some contacts on that website to get in touch with. The other thing just to mention today, I'm going to invite Dr. Marcus Gattani from ECU just to give a quick overview of the research project that's coming up.
Hello.
Yep.
Can you hear me? Okay. Yeah, look, thank you very much. A very interesting series of presentations and amazing information. Some of the issues that have been raised today are part of an international project looking at the use of real-time monitors and comparing that to the conventional assessment techniques. So in particular, looking at how we can calibrate the outcomes of a real-time assessment to the conventional techniques, developing an algorithm to automatically calibrate the data so that you can use it to compare to various standards, and collecting a whole series of data that we can then use to assist international organizations in setting the exposure standards. I've just asked Bo if she can upload a simple letter that I've put in that to which is an expression of interest. What we're doing is we've got a carousel device which allows us to take 12 samples simultaneously, and it rotates at about half a revolution to 3 revolutions a minute, depending on various conditions. And we're looking for people to host that piece of equipment in their operations. We'll hopefully using equipment that we've either had donated or your own equipment. That data will then be analysed with an international group to come up with the algorithm and a whole series of academic papers and guidance notes. So I'm looking for 2 or 3 things. Obviously, people to host us on their site so we can take the monitoring and provide some skills in running that equipment for us. If you've got loads of money sitting in a wallet somewhere, we're also after a little bit of money just to help us with some of the costs. Not a great deal. The whole project is only costing us about 100,000 because we've got lots of people coming up with in-kind support. And the last thing is that if anybody out there or their colleagues are interested in doing a PhD, this is an absolutely outstanding opportunity for doing an internationally significant PhD on this project. And if we can get the funding, then I think we could probably have a scholarship associated with this to enable someone to go full time. So yeah, very interesting project that hopefully will progress some of the issues that Luke and Candice have said. So thank you for the opportunity of mentioning that, and I look forward to hearing from you.
Thanks, Marcus. I think that, it is a really key thing with that ability to link to the exposure standard. That comes up a lot. I saw in the chat people were asking that question, and I think, having a target concentration that's well thought out is a way of getting around that at this stage. But certainly, the more that we can rely on this, it certainly has a lot more benefits compared to our traditional way of sampling. So thanks so much. I think that's a good one to get involved with if you can. So Bo has shared that. And the last one I wanted to share was an ABC article that Kate Cole fed into last week, which was just really interesting. I put the link up there around, applications of CO2 monitors in real time. So looking at, CO2 as a surrogate for, the COVID risks. So, as that increases, it's an indication that the ventilation is not flowing very, the air exchange isn't happening very often, or it might be an enclosed environment. So you can gauge your risk as well. And, Kate talks about how she, carries one on her person and, will go into different environments and gauge whether or not she can tolerate that risk or not, which I think is a great thing from a personal perspective. But there is talk about it being implemented in schools, in classrooms in the future, particularly with the vaccine ages and things like that. I think that is a consideration. So another very interesting application of real-time monitoring in relation to the COVID-19 pandemic. So a good one there. So we just really want to say thank you to everyone for your engagement in the session, for the chats. It's been fantastic to see a lot of discussion and questions and knowledge sharing. And I want to say thanks to Luke. It's been a great opportunity, I think, for us to co-present and collaborate and come from very different backgrounds and perspectives on this, and our experience is diverse. So hopefully that's provided some good input for people who are coming from different backgrounds in the session as well.
Thanks very much, Candice. Yeah, it's been great to collaborate on this and show the two different points of view on this, an internal hygienist versus the consultant, and how we both see it from different angles. So it's been fantastic. Thank you, everybody.
Thanks, everyone. And I'll just finish with the last slide of our contact details. So if there are any questions that we didn't get to, the chat was actually really active. So I think I probably missed quite a few things, but please feel free to reach out to us. We've got our email contacts there if you do have any follow-up questions. And yeah, look forward to catching up with you all again soon. Have a great day.